right, this is Honors Algebra 2 Pre-Calc. We are doing section 6.4 in the text for Pre-Calc, which is the angle between two vectors. On page 441, let theta be the angle between two vectors u and v. We can find angle theta by using cosine theta equals the quantity u dot v over the magnitude of u times the magnitude of v. So, we're going to go ahead and do example 3 that lets us do this. So I'm going to show you what I mean by the angle between these two vectors because I think that might help a little bit with the visual. So if we go ahead in quadrant 1 where I conveniently located both of these vectors and draw u and v, right? So again, forgive my terrible drawing skills. It's just the nature of dealing with me and math. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so vector u, which I'm going to do in green, right, is from the origin, 1 unit to the right and 4 units up. So this is my vector u, right? That's u, and I'll just put that in green so you can see it. My vector v, which I'm going to do in blue, is from the origin 1, 2, 3, 4, 5 units over and 2 units up. So it's right here. That's my vector v, right? So the theta that we're talking about in this problem is this angle between them, right? That's the theta we're talking about in this problem. So beyond that, I'm basically able to find this angle by simply memorizing the formula. So it's up to you if you want to find u dot v separately ahead of time, and if you want to find magnitude of u, magnitude of v, that's what I would suggest doing, right? So the first thing I would probably do is find all 3 pieces of this information. I would find u dot v, get the number. I would find magnitude of u, get the number, and I'd find magnitude of v, get the number, and then I would type into my calculator that theta, well, I would type only this side, the cosine inverse of whatever those quantities were, right? My u dot v is a number that I have, and then I have my magnitude of u and my magnitude of v, right? So I'm going to inch this over so you can see it. But if I were you, I would find all 3 of these numbers first and then just be able to plug into my calculator that it's the inverse cosine of those quantities. I can see just based on the visual I have that I should get an acute angle because both of these angles are in quadrant 1. The angle between them is clearly smaller than 90 degrees. So, I'm going to go ahead and find u dot v, right? So I'm going to find u dot v, and that's going to be the product of the x components, right, which would be 1 and 5, so that's a 5, right, plus the product of the y components, which would be 4 times 2, so that's an 8. So I get that u dot v is a 13, right? My magnitude of u is going to be the square root of 1 squared, which is 1, plus 4 squared, which is 16, so I get root 17, right? And I get that the magnitude of my v should be the square root of 5 squared, which is 25, plus 2 squared, which is 4, so I get root 29. So when I'm typing in my calculator here to find my theta, I'm going to get that my theta is the inverse cosine of a 13 divided by, in parentheses, root 17 times root 29. Now you could actually make it a root 17 times 29 where the 17 and the 29 are both inside the root because that's how roots work, and that's totally fine if that's a thing you want to do, but you don't have to. So I am in degree mode because all these problems, this particular section, have been degrees. Most of these problems are going to be word problems that you'll see in like a physics situation as we move forward where there's force and work and all sorts of crazy vectory stuff. So because of that, you'll find a lot of the answers in this chapter are using degrees instead of radians. We've seen other chapters where radians were more common. Certainly when you're in calculus, you're going to find that radians are the default. You never want to take an AP Calculus test in degrees. That's a tragic, tragic misstep. All right, so I'm going to do second cosine. That's how I get my inverse cosine, right? 13 divided by, in parentheses, the square root of 17 times the square root of 29. Cool. Notice I did all the heavy lifting of finding the actual values myself, and then I just typed them into my calculator and hit enter, and I get an angle of 54.162 degrees, which totally fits with what I can see with my eyeballs, right? So I get that theta is approximately a 54.162 degrees. That's the angle between those two vectors, and again, that totally jives with what I can see with my eyes. We always want to have a good concept about whether our answer is reasonable.